Okay, good morning. Happy May 18th. It's nice to make these videos again. I missed making them. I missed talking to you. I missed Zoom. Thank you for everyone who did. I ready. It really helps me next year and Miss Loster next year to kind of figure out where we need to place you, what we need to learn, what we need to teach, and so it really helps us out. I was really proud to see how you guys did on it. So you did learn something this year. How exciting. Okay, today we're doing student handout 4 in your unit real number system. So if you have that, you could get that out. We're going to be talking about rational numbers and irrational numbers. Now, this is just, remember guys, math is just a language. It's just, sorry, I just moved my chair. Math is just a language. So we have to classify things in math, just like we do verbs, nouns, and all that kind of stuff. So when we look at math, we really just look at two types of numbers. We have rational numbers and irrational numbers. IR, in case you wonder what that stands for, it just stands for kind of like the opposite, or irregular is not regular, right? So irrational numbers are not rational numbers. So let's talk about what rational numbers are. Rational numbers, honestly, are everything you're used to seeing from kindergarten and on. So rational numbers they could be written as fractions or decimals. So you're like, okay, Ms. K, that's almost every other number. Kind of. Rational numbers include terminating and repeating decimals, and we've seen repeating decimals. Remember when we have like that 2/3 is repeating 666. And rational numbers are the square roots of perfect squares. And remember what perfect squares are. When we have the square root of 81, that's a perfect square. The answer is 9. So those are rational numbers. Let's talk about irrational numbers. Irrational numbers cannot be written in fraction form. That means irrational numbers include non-terminating, non-repeating, and anything that is a non-perfect square. So remember how we said 81 is a perfect square because it gets 9? Well, guess what's irrational? The square root of 82 is irrational because it doesn't come out perfect, right? Anytime you see on your calculator that it doesn't end, it's non-terminating. So if you divide them, it's non-terminating and non-repeating decimals. The most famous irrational number is pi. So pi is irrational. It goes on forever and it doesn't repeat. Okay, so let's take a look at this. So let's fill this out. What do we think about negative 12? Well, let's ask ourselves that question. Can negative 12 be written as a fraction? Of course it can. It could be as, so it's rational, and it could be written as a fraction. And what's the fraction of negative 12? Well, negative 12 over 1. Here's the famous pi. Remember, pi goes on to 3.14, and it goes on and on and on. So that's irrational because it never ends, so we call that non-terminating, and it's non-repeat. I'm just going to abbreviate there. Okay, what about 0.6? Can this be written as a fraction? I hope you said yes. It's 6 over 10. So it's rational. It could be written as a fraction. And it's also a terminating decimal. It's just 0.6. It doesn't go on forever and it doesn't repeat. So there's two reasons, right? 7 over 8. Well, that's rational. First of all, it's written as a fraction and it doesn't repeat. How about this? 0.12345 and you notice the 3 dots? Irrational, right? Because it's non-terminating and non-repeating. Okay, let's take a look at this one. 0.3 with the bar above it. Ooh, I might trick someone on these. This one's actually rational. Why? Because when we do this, it means it repeats. So anytime it repeats like that, that's a rational number. Okay? Let me show you the answers to these. I'll be nice. And you could pause this and just write these down so it could help you with your homework, right? Remember, the square root of 20 is irrational because it's a non-perfect square. If it was the square root of 36, then of course that would be rational. Or here you go. This is a good example. The square root of 121 is negative, because there's a negative out here, 11. Okay, perfect square. All right, not bad, right? Okay, so let's see if our homework today is going to be this page, oops, and your homework page. Okay, so homework 4. So let's just do an example of number 4. Okay, state where the given values are rational or irrational. Well, A, rational. Why? Because it's a terminating decimal. It just ends. Aha! You see those 3 dots? Irrational. It doesn't repeat and it doesn't end. Aha. So non-repeat. Non-term. And then the last one, 3.567 with a line over it. What is that? Rational, because it's repeating. Okay, get the hang of it? Not bad. Okay. I like this one. Shall we do one of them? Okay, I'll do one of them for you. Hold on. Let's do this. Okay, so let's do this. Now, the square root of 30. Is it a perfect square? I might just write my perfect squares because I need to know what they are. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So these are my perfect squares. So is 30 a perfect square? Absolutely not. So it's irrational right away. It's not a perfect square. Aha! But 6 plus 30 inside the square root, well, that just means 36. Is that a perfect square? Absolutely perfect. So it is rational. Now this one, you think that you could add these together, but actually you can't, because remember PEMDAS, we do our exponents and square roots first. So these two are irrational because when I solve these, I'm going to get a non-repeating, non-terminating answer. Okay, that's my help for you today. Good luck. I think you're going to do great on this. Can't wait to see you guys at Zoom, and we'll talk soon. Yay!